Hi, in this problem we're going to work out this integral. This integral is from a book written by H.B. Phillips. He wrote this book in 1917, and the book is called Integral Calculus. He was an assistant professor at MIT. This book should be available for free online on the internet. Now, this problem is in the book, but no solution is really given. He just gives like a one-line solution. So I'm going to go through all of the details in this video. So first, note that 0 is between -1 and 1, and this function has a vertical asymptote at 0, right? It blows up, and so there's definitely a discontinuity at 0. So what we have to do is we have to break it up into two integrals. If you were to do this problem incorrectly, you would get the incorrect answer. For example, let me show you the wrong answer. So if you're just bad, like if you want to be bad, you bring it upstairs. You integrate, so you add 1 and divide by the results. So if you add 1, you get x to the -1, divide by -1, so you just get a negative there. All right, this is the wrong way to do it, okay? So you plug in 1, so you get -1 over 1, minus, plug in -1, -1 over -1. You would get -1 minus 1, so you would get -2. That's wrong, right? That's not the answer. You can't do that. So this is not correct. The correct way to do it would be to break it up at the problem point. The problem point is 0, so this is really -1 to 0. And let's write it as x to the -2, since that's what we're going to need to do anyways to integrate. Plus, and then from 0 to 1. So that's typically what you do with problems like this. You want to break them up at the point of discontinuity. Then what you're supposed to do is you're supposed to replace the issue number, which is 0 in this case, with a variable, and take a limit as your variable approaches that number. So I'm going to use the letter b for this one. So this is the limit as b approaches 0. And this is going to be approaching from the left, and I'll explain why in a second. X to the -2 dx. Plus, and I'll explain why in a second. And then I'm going to replace this one with c. And this is going to approach from the right, and I'll explain why in a second. Okay, now let me explain the directions here because I think this causes a lot of confusion. I'm going to do it over here. So here's a picture of our interval. Here's -1, here's 1, here's 0. We chose b as the variable for the first integral, so I'll place the b here on the number line. And I did that because b is between 0 and -1, so you see here it's between 0 and -1. Oh, look at that, it's approaching from the left. Boom. C is between 0 and 1, so it'll go here on the interval. Oh, look at that, it's approaching from the right, right? Perfect. From the right, from the left, from the right. Perfect. So now we just integrate these. This is the limit as b approaches 0 from the left. Here you add 1 and divide by the result. So -2 plus 1 is -1. So you divide by -1, so you'll get x to the -1 over -1, which is just x to the -1 like that. I probably should have written it as -1 over x, but let me do that. Let's do that. That's why the universe created erasers, right? Because it's really, let me show you down here, it's really x to the -1 over -1, right, using the power rule. So you can write it like this, right? That's what I want to do. So I'm going to do it up here. This is -1 over x. So we'll go from -1 to b, and then plus the limit as c approaches 0 from the right, -1 over x, and we're going to go from c to 1. Really nice, right? So now you plug in the b first, subtract, then plug in the -1. So this is the limit as b approaches 0 from the left. Plugging in the b, we get -1 over b minus -1 over -1. You got to be very careful here. Plus limit c approaches 0 from the right. It's going to be -1 over 1 minus -1 over c. Okay, let's clean this up a little bit. This is the limit as b approaches 0 from the left, -1 over b minus 1 plus the limit as c approaches 0 from the right, -1 plus 1 over c. Okay, so here's where we have to do some thinking. So let's focus on this one first. So b, obviously you can't plug in 0 because you're going to get 1 over 0, so it's undefined. So obviously these limits are not going to exist. So what can we say that best describes our current mathematical situation? Let's do that. So as b approaches 0 from the left, we have this expression, we have this fraction, negative 1 over b. So it's getting infinitely close to 0. For example, negative 0.00001 over negative 1. If we pick a point in time to stop, maybe b, at some point b will take on this value. So you have a negative number over a small negative number. This is big and it's positive. So this is going to approach infinity. Infinity minus 1, so this is just infinity plus. Here, same thing, it's 1 over a very small positive number. This time we're approaching from the right, so it's positive, right? Over here, we were approaching from the left, so it was like getting close to 0, but it was negative. Here it's getting close to 0, but it's positive, so like 0.00001. If we were to pick a moment in time where c is approaching 0, if you just stop it for a brief second, you see it gets smaller and smaller and smaller. So you have numbers like this and smaller, right? Infinitely many numbers approaching 0. So this is big. So infinity plus infinity, so you just get infinity. So you would say that this integral, the original integral, negative 1 to 1 of dx over x squared is equal to infinity, right? So you would say that the integral diverges. More modern books will say whenever this happens, we say that the integral diverges. And if you get an actual real number, then you say the integral converges. Now, Phillips mentions nothing of this in the book. He goes over the example that I talked about here. He shows how it's negative 2. And then he says that it doesn't make any sense, right? Because he says, since the integral is obviously positive, the result negative 2 is absurd. And then he goes over here and just basically shows you that it's infinity plus infinity. Now, what is he talking about, the integral obviously positive? Let me explain that. I'll explain it here. If you look at the graph of 1 over x squared, looks like this, right? And so we're basically integrating from negative 1 to 1. So we're basically looking for this area here. Right? And again, this graph goes up forever, so this keeps going and going. Let me just try to do a better picture over here for you. So it does this, right? It gets infinitely close to the y-axis. Right? This is the graph of y equals 1 over x squared. This is the x-axis. This is the y-axis. And so what's happening is we're integrating from negative 1 to 1. So we're getting the area under the graph. But you see what happens here is that this area goes up forever because the graph goes up forever. So when you integrate from negative 1 to 1, intuitively, it should be infinite, right? It's infinity because you have like this infinite area. Basically, that's the idea. You have an infinite area. And I put it in quotes because a lot of times people will say, well, area can't be infinite, it has to be finite, right? It just depends on the definitions that you're using and the context of the problem. So, but yeah, so that's the idea behind the problem. Kind of cool. I hope this video has been helpful to someone. And I went kind of fast, but hopefully some of it made sense and hopefully you learned something. Good luck.